Hi, in this video, we will perform operations on matrices. But before that, let's look at example 1. What is the order of matrix A? And then we want to identify what is the A21 element and A13 element. An order of a matrix is written as M times N, where M is the number of rows and N is the number of columns of a matrix. So how many rows and how many columns do we have for this matrix? There are M rows and N columns. For this question, there's 1 and 2 rows and there's 1, 2, 3 columns. So how to write your order will be, you start from the rows and then your column. So it's 2 times 3. What is the A21 element? The A21 elements means that the first number here is referring to the row and the second number here is referring to the column. So what is the element situated at the second row and the first column? Second row and the first column. The element is -2. Look at the element intersecting both rows and columns. What about the element 1, 3? It means that it is situated at the first row and the third column. Let's highlight the first row and then highlight the third column. The element intersecting both rows and column is element 1/2. So that is our A13 element. Equality of matrices. Two matrices are equal if they have the same dimension and their corresponding entries are equal. What does dimension means? Means that they have the same order. Look at example 2. If you have A and B as shown, and if A is equal to B, find the values of A, B, C, and D. Since both matrices are equal, we can just equal them and put them side by side and an equal sign in the middle. Next, since we want to find the value of A, B, and C, and D, we have to compare the elements. Like this, the first element, 3 minus A, is compared with the first element of matrix B. We can just solve this algebra to find our A, which is -6. Next, to find the value of B, B is situated here in matrix A, which is in the second row and second column. That means we have to compare with the second row and second column element of matrix B as well. Equate them and you find your value of B, which is -2. Next, your C is situated here in the first row and second column of matrix B. Then look at matrix A. We have to look at the first row and second column as well. We compare those values and you find your C is equal to 0. Next, your D is in the second row and first column of matrix B. Compare it with the second row and first column as well for matrix A, and you get your value of D, which is -2. Operations on matrices. We can add and subtract matrices, but we can only add and subtract matrices of the same order. If the matrices have different orders or different size, then you cannot add or subtract. Let's have a look at example 3. 3A, we want to find A plus B. Remember, to add matrices, they must have the same order. Let's first write down the order for A and the order for B and C. The order for matrix A is, we have 2 rows and then we also have 2 columns. Matrix B has the same size of matrix A, which is 2 rows and 2 columns, but matrix C has 2 rows, 1, 2 rows here, but 1 column. So it's 2 times 1. Remember, for matrices to be added together, they must have the same orders. Do we have the same orders for A and B? Well, yes we do. Both has 2 times 2 orders. To add these matrices, just put the matrices side by side with a plus sign in the middle, and then you add elements one by one according to their order. So 1 plus 4 will be in the first row and first column of the matrix. Next element, 2 plus 3 will be in the first row and second column. Next element 3 plus negative 5 will be in the second row and first column, and last element is 4 plus 6. It will be in the second row and second column. Just add those numbers up and you get your final answer. Question B. Can you subtract A with B? Remember, in order for you to subtract matrices, they must have the same orders. Do we have the same orders for A and B? Well, yes, we do have the same orders. So you just have to write the A and B matrices side by side and put a minus sign in the middle, and then subtract the elements one by one. 1 minus 4, 2 minus 3, 3 minus negative 5, and then 4 minus 6. Solve this and you get the final answer. Example C, A plus C. Do they have the same orders? One is 2 times 2, another one is 2 times 1. They have different sizes or different orders. So we can't solve for this question. Scalar multiplication. Given the matrix A, we want to find 2 times A. Each element will be multiplied by 2. Just multiply all of the elements with 2 and you get your final answer. These are the properties of addition and scalar multiplication on matrices. Please have a look. A and B here are matrices. Alpha and beta are constants or scalars. Multiplication of matrices is not the same as addition and subtraction of matrices. For you to be able to multiply matrices, the number of columns in A must equal to the number of rows in B. An easy way for you to remember this is make sure the numbers right in the middle of the orders are the same for matrix A and matrix B. This means the column of A has the same number as the row of B, and your resulting matrix will have the order of M times B, which you get it from the rows of A and the columns of B. How to multiply two matrices? You just multiply the elements together from the first row and the first column, and then you add it up with the other element. You have to do this one by one. Let's look at this example. To multiply these two matrices, you have to first check their compatibility. Can they be multiplied together? The first matrix has 2 rows and 3 columns. So the order is 2 by 3. The next matrix has 3 rows and 2 columns. So it's written as 3 by 2. Remember, for you to be able to multiply matrices, the number for the first matrix here of the column must equal with the number of the rows for the second matrix. Do we have the same number there? Well, we have the same number. That means we can multiply the matrix. So what will be the resultant matrix? Our final matrix will be in the order of 2 by 2. To multiply these matrices, you have to look at the first row and the first column of the second matrix. Multiply each of the elements one by one. 1 times 2, and then plus with the second element here, 2 times negative 3, and then the last element, 3 times 2. If you have more elements in the rows and columns, keep on going. But now we only have 3 elements, so we just stop there. Since we are looking at the first row and the first column, that means our answer will be situated in the first row and first column of this matrix. Next, to find the answer for the element in the first row and second column, we have to multiply the first row with the second column. Multiply each of the elements one by one to get your value in the first row and second column. Do the same for the second row and first column. Your answer will be in the second row and first column of the new matrix. Next, do the same for the last column, and your answer will be situated in the second row and second column of the new matrix. And your final answer is just 2, 12, 6, and 3. Example 6. Given matrix A and B, find A times B and B times A. Let's write A and B next to each other. Can we multiply these two matrices? Remember, we must check the orders. The order of matrix A is, we have 3 rows here and 3 columns, so it is 3 by 3. The order of matrix B is, we have 1, 2, 3 rows and 1 column. So the order of B is written as 3 by 1. So can we multiply these two matrices? Remember to check the value of the column and the row of the second matrix. If they are the same, that means we can multiply the matrices, and the resulting matrix will be just 3 by 1. 3 by 1 looks like this, which means we have 3 rows and 1 column. To find the first element, which is in the first row and first column, we have to look at the first row and first column. First row of matrix A and first column of matrix B. Since there's only one column for matrix B, that's the only column that we'll look at. Multiply the elements and add them up. Next, for the second element in the second row and first column, look at the second row of matrix A and column B. Multiply the elements 1 by 1, 5 times 1, plus 1 times 0, and then plus 6 times 3. Do the same for the last element. Sum your values and you get your final answer. Next question, B times A. Is this possible? We know that the order of matrix B is 3 by 1 and order of matrix A is 3 by 3. Compare the numbers in the middle. Do we have the same number there? Well, we don't. Another one is 1, another one is 3. Since the number of column in B is not equal to the number of row in A, we cannot multiply these two matrices together. So there is no solution for this question. These are the properties of matrices. From the previous example, you can see that even though we can multiply A with B, but it's not necessarily mean that B can be multiplied with A. So matrices are not commutative. Thanks for watching.